All right, so today what we're going to do is we're going to continue talking about two-way tables. You're going to see two-way tables used a lot. As a matter of fact, on the assessment, you're going to have to read information and probabilities from a two-way table, and then you're also going to have another question where you have to create your own two-way table from information given. And so those are the two skills that we're going to practice today. All right? Now, but before we do that, I want to put up some notation so that you can remember some things that we've already done. All right, so who can tell me what that notation means? Yes? So, what does the P stand for? Probability of A, right? So that's just read as the probability of A, yeah? Okay. Who can tell me what this is the probability of? Not A. Excellent. Good. What is it called? So we have to use this little apostrophe to stand for not. What is it called when you have that symbol? There's a special word for that kind of probability. Starts with a C. The complement. Right. Good, good. So make sure you know. So probability of A and the probability of not A. Okay? Also remember that, oops, that didn't work out really well. There you go. That they always add, if you have the probability of something and the probability of not something, always adds to what? 1. Good. Or 100% if you're doing it as a percent. Both of those mean exactly the same thing, right? Okay? Because you can either have something happen or something not happen. Those are your only two choices. Yeah? Okay. So you're going to see that notation. Now, in Education Perfect, they like to use probability of A, probability of B instead of writing it out, which again, remember we talked about that. That's perfectly fine as long as you provide a key to what it stands for. So if I wanted it to be the probability of a student at Queen Margaret in year 7, then somewhere I need to have that it says A equals year 7 students at Queen Margaret. Okay? Now, that's easy with a two-way table, because with a two-way table, you're already going to have categories at the top, right? And so what you can do is, say if this one's cats and this one's dog, you can just say cat is A. Whoops, or let's change that a little bit. I'm sorry. I don't want dog next to cat. Dog would get its own section, right? So if that's cat, we could call cat A. And we could call not cat, what? A prime, as it's called. Remember, prime, the complement of A, okay? Then, if this was dog, and we call that B, there you go, that's where you get a different letter, totally different category. Then what would not dog be? B prime. There you go. So remember the notation. You can use those abbreviations. It makes your life much, much easier. But I could not just call them A and A prime if somewhere on the page I did not have what they are, right? I need to be able to say, if I wrote probability of A prime, I need to be able to see on the same page that means not cat, right? So don't use abbreviations if you don't have a key to your abbreviations. But with two-way tables, it's easy. You can just put A prime, put them right on the chart. Okay? And we're going to encourage you to do that. Another thing that you're going to see today that you may or may not have seen before is something called a Venn diagram. Now, you don't need to know too much about a Venn diagram, what it is, but you need to be able to read it slightly to be able to tell what's happening. So Venn diagrams are simply sets of circles, and the data is written inside those circles. Now, what do you notice about these two circles? What do you notice about right here? Yeah, so they're the same there. So they've overlapped, yeah? So that section represents where the items that are in both sets. So if I call this one set A and this one set B, this area right here is A and B, right? They both exist there at the same time. We talked about set notation for that. What's the word for that in the symbol? Intersection. Good job. Okay, and can you remember what the symbol is? The one that, that funny horseshoe thing, but opening downward. All right, so that's intersection. Good. All right, what was the other one, just out for kicks? Intersection and union. Good. And what's the symbol for union? The horseshoe shape, right side up. Okay? All right, good job. Now, so you can have a number here. So let's just say we have 5. And just get rid of this shading. And we have 6, and we have 2, and then out here in the middle of nowhere, I have 12. First of all, how many items are in both A and B at the same time? 6. How many items are only in A? 5. How many items are only in B? 2. And how many items are in neither A or B? 12. Pretty easy? So we're going to be looking at that. They're going to give us the data in a couple of different ways. They're going to tell us in words, but they're also going to give it to us on some Venn diagrams, so we need to just talk a little bit about them just so you can see. So, center section is where they're in both. This was only A, that's only B, and this one is neither one. Make sense? And you'll see several of these as we're going through. Just want to make sure that you're familiar with them. So what we're going to do is we're going to be given information either from a Venn diagram or from a paragraph, and we're going to use that information to create our own two-way tables. All right? So let's just refer back to what a two-way table looks like. Remember that a two-way table has things that are going up and down. What are those called? Columns. Imagine that, since I just said that. Yeah. Okay. And it has lines going across. What are those called? Rows. Okay. So if this is A, this is usually not A. If this is B, the one below it is usually not B. Not always, but usually. Right? That could be blue and red. Remember the cars when we were looking at different cars or something like that? What is always at the end of each row and at the bottom of each column? Total. Yes, I'm sorry. So I've written that one wrong. Sorry. Nobody going to correct me. That's B and B prime. Sorry. This is the total. And this one is also for total. Make sure you put those in there. And so what is this one? Yeah, that's your overall total. That's everything all added together. So the total of the totals. So this one plus that one. This one plus that one. And they should always equal. So you can always check. Okay? So you have rows, you have columns. What's one individual piece called? A cell. Excellent. So just like in computers, right? So a cell. So the one I circled is the intersection of what? A prime and B prime. Whatever those would be, because you'd have specific categories for those. Right? If I wanted to find the probability for that, okay, let's say this was 7 and this was 20, for example. The intersection of how many things are in that cell? So that's the probability of A prime and B prime happening at the same time, isn't it? So it'd be 7 out of how many total items are there? Out of 20. So that's the probability. And as a fraction, you can write it as a fraction, but pay attention. Sometimes they're going to ask you to check. If it is a fraction, you need to make sure to see if it will reduce or simplify. In this case, it won't. We could also be asked to do it as a decimal. So remember, you're all supposed to have your calculators out right now, because I'm going to ask you, what is the decimal for 7 over 20? Get them out if you don't. Always, every day. Yes? Zero point what? 35? Is that what you got? Good job. Good job. Okay. Or you can be asked to find it as a percent, and as a percent, what would that be? 35%. Excellent. Thank you. Okay? So always have those calculators out and ready. Good. All right. So that's what we're going to be doing, is we're going to be practicing building our own two-way tables. And again, looking at the information in different ways, because it can be presented to you in lots of different ways, and you need to be prepared to deal with all. Okay. So let's just go to our Education Perfect lesson. Again, we're just talking about using two-way tables, to calculate probabilities. So, first thing you're going to do is looking at how you can turn a Venn diagram into a two-way table. Yeah? So, looking at the information here we have a two-way table, and it's just B and not B, and A and not A. You could just as easy as written B and then B prime there. So they're just numbers. There's no real specific categories. Generally, it would be like cats, dogs, whatever. Okay, and you'll see lots of examples. And we're just going to go through and see how we can translate those values from the Venn diagram to the two-way table. Okay? And if you look at it, first of all, A and B, if things are in A and B on the table, that means that they're in both on the Venn diagram. So that category will always be that little slice, that little football-shaped slice in the middle, right? Not a football for y'all, I forgot. A rugby ball, maybe? Okay? That place in the middle. So if it's in both A and B, it's always going to be in this section in the middle, right? Well, then, if it's not in B, that means it's only in what? A, right? It's in A and not B is the intersection. So in A, but not in B. Here at the bottom, it is in B, but not in A, so that's where they got the 6. Right? It's in B, but not in A. Okay? And then finally, the last one, 16, is not in B or A, and that's always found outside the circles. It's in none of them. And so that's where they get the 16. Make sense? So just remember that every cell has 2 descriptors. And if you remember 2 descriptors for each one, then it's easy to put these in order and where they need to be. So, this cell here, that's the cell what? A and B, both of them. Okay? Good job. Right. And then from those, we could then get, obviously, what's missing from this two-way table? The totals, right? Always make sure your totals are on there. For every two-way table you do. They sometimes leave it off, but make sure for every two-way table you do, always put those totals in. They're critical to making it work. Okay? So, let's just do this one. About animals with stripes and spots, we're going to put it into a two-way table. We're going to just walk through this one together. So here you see we have 2 categories, stripes and spots. So go ahead in your notes there in examples and draw out, it's an example we're going to work on, draw out a two-way table where the categories are stripes, the other category is spots. So what do you suppose it's going to look like? You're going to have stripes and what? Spots, and also what? No stripes, and what? No spots, and of course you're going to have totals on both of them. Okay? Give that a shot. Excuse me. So we have ours on the board. Let's just walk through this so we can see that we did it and got kind of the same thing. So there you go. What's missing on there is that I am not happy about. Totals. You do not draw a two-way table without totals. Okay? All right. So there they go. Looking at the information, they start filling it in. And they get, eventually, there you go. There are all the values. And then they put in the totals. Okay? And again, doesn't matter if you put stripes, no stripes, and spots, no spots, right? The order of them doesn't make the slightest bit of difference to your final table. Okay, excellent. All right, so here we go. Can you see that all at one time? Oh, well, maybe a little bit. So what I'm going to do, so we have fruit and vegetables. I'm going to have to bring it down a little bit. And, all right, when they start talking about getting the probabilities, they start using abbreviations again. And you can do this in your categories. So, for example, if you had cat, you could put that as A, not cat as A prime, right? And then when you're writing out your probability statements, which remember, your answer is not correct without a probability statement, right? So if I just write 57%, is that correct? Nope. I have to write the probability of something is 57%, okay? So make sure that you put in the probability statement. That's that part that says probability and then the bracket and then the thing inside. And as long as you're on the same page, you can abbreviate with A's and A primes. Okay? All right. So remember that, and they're just we talked about this earlier. Probability of A is the probability that A does occur. Probability of A prime is the probability that it does not occur. Remember they use PR. I'm happier if you just write capital P. Okay? All right. Now, so let's look at some of these. Again, just a reminder, the probability is the number of outcomes, of the successful outcomes over the total number of outcomes. So here, the following diagram shows the number of animals with wings, a beak, or both. Right? And so you see wings, no wings, beak, no beak, and you've got your totals. Harold is looking at the probability that an animal has a beak. So that's any animal that has a beak. So looking at the cells for beak, here's the header for beak. So does it have anything to do with wings at all? No. So that's every animal that has a beak. So that's those two added together. So that how many animals total have a beak? 40, right? So that's a success in our scenario here, right? So probability of having a beak is 40 out of how many total animals in the study? 72. And of course, 40 over 72 would simplify that. It'll reduce as a fraction. You could also change it into a decimal and then change it into a percentage. Okay? So everybody see how that works? All right. Then he wants to know how many don't have beaks. So, again, we're just going to go to the row for no beak, and it doesn't matter if they have wings or not. So that's how many animals? 32 out of how many total? 72. Right? So this is kind of like the exercise that you did last time when we weren't here together. Okay? All right. So let's just walk through this one so you can see the whole thing. So again, they're doing no beak. It's 32 out of a total of 70 animals, or 72 animals, I'm sorry. Okay. Which they reduced it to 4 over 9, changed it to a decimal of 0.44, rounding it to 2 decimal places, which became 44.44%. Okay. If you're in a situation like this, because what happens when you do 4 over 9 is it just gets a 4 and it repeats. When you're doing a decimal, round it to 2 decimal places. But as a percent, you also want 2 decimal places. So anytime you're doing these as a decimal, always go to 4 places. And that repeats. And that way, when you do change it to a percent, you'll get enough places, because you wouldn't round this to 44%. Okay? All right. There we go. Here we go. Following diagram shows the animals with wings, a beak, or both. Jessica is now looking for an event that has either a beak or wings or both. So a beak or wings is a success. Go. Just circle think about the cells and put the numbers in. See if you can find out how many animals have a beak or wings. Then we'll work it together. Okay? Just 3 minutes. Discuss it with yourselves. Actually, 2 minutes should be plenty. Beak, probability of beak or wings or both. All right? This is the inclusive or. Let's just walk through this one together, just because I want to point out a place where you can make mistakes. So, if we want a beak or wings or both, the temptation might be for some of you to say, all right, here's beak. So everything that has a beak is here. Here's wings. Everything that has wings is there. And add those together. Do you see an issue there? It would be 44 plus 40, which gives me what? Yes?
Because that also includes no beaks and no wings.
There you go. So what we get, well, we're going to include some of those because we have an or situation here. But what's happening is the ones that have both beak and wings are being counted twice. You see? Right? Because we have that number in this total, and we have that number in that total. Okay? So you've got to be careful. And we know automatically, though, if you think about it, that would give us 84 over 72, and the numerator is bigger than the denominator, which means it's bigger than one whole. So, and that cannot happen in probability. Remember, probability, the biggest probability you can have is 1. So you can't have any number bigger than 1. So we knew that we had a bit of a mistake there. Okay, so here it gives you all three. It gives you a reduced fraction, which this one didn't reduce, gives you a decimal rounded to 2 decimal places, and it gives you a percent. Get in the habit of doing all three just so you know how to do all three. Yes? But if I was asking you for percent and you did all three, then you need to circle or put a box or do something or highlight, do something to make sure that I know that the one you're answering in is percent. Okay? So, usually, however, you're going to find that we ask these in a question. So you would have to say 56.16% of the students had only had chocolate. Right? So you would be describing it in a sentence anyway. Okay? But get in the habit of doing the math for all three. That way you'll be in much better shape. Okay?